Hello, hi Rahim. I hope you are doing good. Now, in the last class, we discussed about the IP addressing, right? We discussed the IP addressing, and we have also looked upon how they are made up, right? What are the things that are going behind the IP addresses? Okay, I talked about the INA and how it has set all the priority bits here in order to fix the classes, class A, B, and C. Also we use D and E, but they are not used as in the communication, but for the multicast and experimental purposes. Okay, now we will start today the topic subnetting. All right, now subnetting means to, as you can assume from the name, subnets. Okay, these are two entities. So sub means parts and here net means networks. Okay, so in order to break a big network into smaller networks, we call it subnetting, and the process is the same, subnetting. But how do we do that? Before going into the depth of what the subnetting is and how we do that, I want to share something with you that is interesting, very interesting, and that is the systems that we use, the decimal systems. Okay, now that decimal system is used all over the world, right? In any kind of mathematical systems, there are always two things. The first is the place values, and the second are the digits. These two things made up your decimal system or any other system. Also, same on the other side, you have a binary system where you have place values and digits. I'm going to talk about it in a moment, but let me make sure that you're getting the point from here. Now, in the place values, where we have you know ones, tens, hundred, thousands, how we make those place values? We make them by taking a base 10 and raising it to the power 0 to infinity, whatever we want to. For example, let me raise this to the power of 0. It means 1. Any number raised to the power of 0 means 1. Any number raised to the power 1 is its own number. Any number raised to the power 2 is 2 times of the number. Any number raised to the power 3 is 3 times of the number. 4 is 4 times of the number, and you can go on and on. These are the things, or these are the processes that make us or gives us the place values. Meanwhile, on the other hand, we have 0 to 9 digits. Now these are fixed. Yes, we cannot use any other digits here, A, B, C or something like that. We just have to pick up from any of these 0 to 9 digits and we have to make a number. For example, so these are place values. Let me write it: ones, tens, hundreds, thousands, 10,000s, and on, right? Now, for example, let us say 40195. Okay, these are nothing but digits. Oh, yes. How do we make some sense out of it? We have to put them in the place values, isn't it? How do we do that? Let's have a look at it. I'll put this at place value of 1, which means 10 raised to the power 0 equals ones. 10 raised to the power 1 equals tens. 10 raised to the power 2 equals hundreds. I hope it's making sense as how we actually have to form our decimal system. Okay, now let me raise this thing here because you have understood the idea. Okay, now what we do is we just multiply this with this, multiply. Okay, multiplication. The answer that we are going to get is 40,000 plus 0 plus 100 plus 90 plus 5, isn't it? Now I'm adding these in order to get a meaningful number, and that is 40,195. That's how I find out that this is at place value of 40,000, this is at place value of 1000, this is at place value of 100, and this is at place value of tens, and this is at ones. I multiplied the numbers or the digits with the place values, and that's how I am getting a meaningful number here. Now we can use that. In the same way, we have our binary system. Okay, in binary system we have the same things, a place value, okay, and some digits. What those digits and place values are? Now we were taking base 10 here. Yes, we were raising the power of 10 number 10 to some values, but here the base value is 2. Okay, which means I'll take 2 and raise it to 0. It means 1. As I said, any number raised to the power 0 is 1. 2 raised to the power 1 is 2. 2 raised to the power 2 is 4. 2 raised to the power 3 is what? 8. 2 raised to the power 4 is 16. 5 is 32. 6 is 64, and you can go on and on. Okay. So that is how these place values are working, alright, or being formed. So let me write it down. Okay, here we have the place value of 1, 2, 4, 8, 16, 32, and so on. Okay, meanwhile in the binary system there are only two digits, 0 and 1, nothing more than that. We have digits from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Meanwhile in the binary we have 0 and 1s. Okay, now I'm going to add a number, or I'm going to take a number here, something like this. Okay, and I'm gonna place values here. So it will be 32, 16, 8, 4, 2, 1, or just let's do it this way. Ones, 2, 4, 8, 16, 32, 64. Okay, now I'm gonna multiply them, the same thing I was doing in the decimal system. Okay, I'm going to get a value. 64 multiplied by 0 is obviously 0. 32 multiplied by 1 is 32. 16 multiplied by 1 is 16. 8 multiplied by 0 is 0, 0, 2, and 0. Okay, now 16 plus 32 and plus 2. What are we going to get here? 32 plus 16 is going to be 48, plus 2 is 50. Okay, so we'll say that the binary of 50, now this is a decimal format. Yes, this is in decimal. Where we are converting this binary to decimal in order to make us understand, the humans understand what we are talking about. Now we will say that the binary of 50 is 0, 1, 1, 0, 0, 1, 0. Got it? So this is the binary presentation. Okay, now I've discussed this thing in the subnet or the IP addressing video also, but it was important to revise this. Now what we are going to do is we will do the subnetting part. Okay, I mentioned class A. Remember that? Class A, class B, and class C. Right? In class A we have our IPs from 0 to 127. Yes. Class B 128 to 191, and class C 192 to 223. Yes. This was all about the first octet. Now this is all about theoretical things, because if we take an IP address from anywhere from class A, so let's say 0.1.1.1, okay, this is not a valid IP, not a valid IP. Okay, also this is because the network part is all 0. I mentioned that this is the network part here. Okay, this is the host part, this is the host part, and this is the host part. So this one first octet is 0. That's why we cannot say that, or we cannot identify to which network it belongs, right? This is also reason it's not a valid IP. The second thing is 127.0.0.0 is called a loopback address. Loopback address. Okay, and we cannot assign this to any IP, to to any computer, any PC, any laptop, mobile phone, anything like that, any end device. It is, in fact, it is already pre-configured on an interface. This is used for diagnosing purposes, okay, or also troubleshooting purpose. All right, so there are multiple purposes for loopback addresses, but any IP address from this range, from 0.127.0.254.15, let's say this, that is a random IP address that I wrote. You can ping this IP address and you can identify, or you can come to know whether your interface is working or not. So you will put this command in the command prompt, ping 127.0.254.15, and you will come to know that your interface is working. Okay, so that is the meaning of the troubleshooting and the diagnosing here. All right, now in class A, okay, we had, as I said, that there was a network portion of first octet, all other octets are for the host portion. How do we come to know that this is a network portion, this is the host portion? Yes, so there is actually a dividing line here. That dividing line is the subnet mask. Okay, where we identify that here 255.0.0.0. okay, so basically there are 8 bits here, same as the IP address, 1 2 3 4 5 6 7 8, and there are 8 bits here also, but in the 0 form. Okay, all are zeros. Now you can make an IP address but by putting some random numbers, but in the subnet mask, if you stop the bits anywhere, let's say here, so all the bits ahead of it will be zeros. Okay, we cannot go random numbers, we cannot write our subnet mask like this, 0 1 1 0 0 0 or 1 0 1 or 0, like, okay, so we cannot write this subnet mask like this. We have to be either at ones or at zeros. Okay, they have to be consistent, they cannot take random place values. All right, so these ones actually present network. Okay, now if we put all these networks to 0, right, in the IP address, meanwhile in subnet mask they will be set to 1, all ones, and in the IP address I put all of these to zeros. If I'm going to multiply it, what I am going to get is 0, isn't it? That's why I cannot assign this IP address to any host, because in the first octet there is no network, we cannot identify any network. Okay, so we will not be using it to assign it to any other person, or any other host, or any other end device. We have to at least get one here. Okay. Now coming to the subnetting, let's say we have an IP address 192.168.1.1. Okay, this IP address belongs to class C. Yes, in class C we know we have network, and host, something like this, which means that the dividing line is somewhere here. Yes, the dividing line is somewhere here. Okay, so I cannot change this not one dot, but I can change this last octet. Yes, I can take any value from here and I can assign it to any end device, and they will be able to communicate between the other devices via this IP address because these are the network portions. As far as you don't change the any network bits, you will be good to go and you will be able to communicate within the network if you just change the host bit. Okay, so you have to make changes in the host bit but not in the network. But you say in a real environment where we have employees and we have different departments for each and every company, so let's make a topology here in order to understand what I'm going to say. Let's say that this is a router here, router 1, this is a router 2. Okay, now there are different departments with each router connected. Okay, let's say that there is a sales department here, there is a management department here, there is a IT department here. Okay, and there is a marketing department here, something like this we are seeing, right? So I hope this picture is being clear here. Now there are at least 5 networks that I need. Yes, the first network is here, this is the first. Second network is here, this is the second. Third network is here, fourth network is here, and the fifth one is here. You know, we have to assign the IP addresses between the routers also, so we need different network for that, because routers work only when we have different networks on each and every interface of those routers. Okay. So let's move on. Let's say that we have different number of hosts in each and every department. Okay, let's say we have in sales we have, let's say, 50 people. Okay, in management we have 100 people, in IT we have 200 people, in marketing we have maybe 35. Okay, around 35. All right, and here we need 2. What is 2? 2 hosts, because one host will be assigned, one IP address will be assigned here and one IP address will be assigned here. Okay, now 50 hosts are required here, 100 hosts are required here, 235. Now subnetting can be done in 2 ways. Okay, the first one according to the host, according to the requirement of the host, and second one according to the number of network. All right, so now there are 2 options. You can go either with the host option and either with the network option. This will be assigned to you from your admin or from wherever you are working. They will get you know that what you need to do, whether you need to go with the number of hosts or the number of requirements, number of network requirements. Okay, and we have 2 different approaches, but not very different, but we have like kind of similar things. Yeah, but they will be understandable by you very easily. Okay, so let's start this thing. Let's do one thing here. I'm going to make sure that it is available for us. Okay, now let it delete this, and let me do one thing. Let me paste it somewhere in the word so that this is easily accessible. Okay, so I'm going to blank document here and paste it. Great. This is the marketing department here. All right, so now this is going to be a picture. Okay, this is the requirement. There are two requirements basically. The picture is something like this. Okay, let's start. We will first go with the number of networks. Okay, now there are 5 number of networks that we need, so we will say that our requirement is equal to 5 networks, isn't it? That's what we were doing here. 1 2 3 4 and 5. We need 5 networks. Okay, how do we do that? So there is a formula for this subnetting part, and that is 2 raised to the power n. This is n. Okay, should be equal to or greater than your requirement. Now this is important and you should note this one down. Okay, 2 raised to the power n, that is greater than or equal to your requirement. The requirement is 5, so 2 raised to the power n equal to greater than 5. Now the main thing here is to focus on this number n. Okay, now I'll explain why, but first let me meet this requirement. Okay, let us solve this equation here. So 2 raised to the power 3 is greater than or equal to 5. Yes, it is. 2 raised to the power 3 means 8, that is equal to, sorry, excuse me, that is greater than 5. Okay, meanwhile if I go with 2 raised to the power 2, is it going to be equal or at least greater than? No, it's not going to work. Okay, that's why I choose 2 raised to the power 3, number 3 here. Now this number right here, let me highlight this 3. These are number of bits to borrow. What I mean by to borrow, let us look here. Now I mentioned you an IP address 192.168.1.0/24 you know 255.255.255.0. These 8 and 8 bits will make up /24. Okay, 24 bits, which means that we have 24 bits reserved for the network portion. Now we are left with the last network or the last octet here, and if I'm going to expand it, it will look something like this, isn't it? It will look something like this. It has 8 bits, right? And these are all zeros. Now before that you have all ones also, so just for the sake of explanation I'm gonna write these like this, right? And that's how it is going to look. Okay, now let's do one thing. These are the number of bits to borrow. Yes, here what I'm going to do is I'm going to borrow 3 bits from the 4th octet. That is, I'll convert this to 1, convert this to 1, convert this to 1, and rest are 5. Okay, so this is basically the meaning of borrowing the bits, and that is subnetting. Nothing but subnetting. That is only the process that we need to know in subnetting. That is the main component. Okay, Meanwhile all other bits are already ones here, so we are not touching them because as I mentioned they all belongs to the network. So we're not going outside of network, but we are actually creating a network in a network. Okay, so we have a big network. It is assigned to you by your let's say ISP. Okay, it has been given to you by your ISP, and you have to divide it in order to communicate different networks or different departments and assign them in a different network. Okay, so what I'm saying is you will assign a marketing department a different network, IT department a different network, management department a different network, and sales department a different network. Why are we doing that? So that we don't need to purchase multiple IPs, and also so that we don't need to waste the overall IPs being wasted here. You know, the overall IPs that you can get here is 256. Okay, I mean including all IP addresses, you can use 256 IP addresses. So if you have a network or if you have a department where you just need 10 people or 10 IP addresses, you're actually wasting 246 IPs, isn't it? So that is the also main reason why we are actually trying to do this subnetting here. Okay, subnetting plays a very important role in the real networks like this. Alright, now we have borrowed the bits, which means that the subnet mask or the slash value here, which was dependable on the subnet mask, and the subnet mask has been changed, so we need to change the slash value here also. And I'm going to write it down again like this: 192.168.1.0, but the slash value is going to be, it was 24 till here, right? 24, 23, it's going to 25, 26 and 27, so I'll write 27. Okay, you know you have 32 bits, so 27, 28, 29, 30, 31 and 32, these are the bits that we are using. So 32 are the overall bits, but slash 27 defines that these bits are actually belonging to the network portion here. Okay, I hope it's being clear here. So slash 27 means that we have done the subnetting. Now if you look at the default subnet mask of each and every class, so in class A you will see that it is slash 8, in class B you will see that it is slash 16. Okay, in class C you will see it is slash 24. Okay, if you see any subnet mask uh, different from these values, these default values, let's say class C, so I was using slash 24, that was the default slash value for class C. If you see anything against these default values, it means that you should understand that there has been a subnetting. We have done subnetting on that IP address. If you find any IP address uh, you know, apart from these very basic and default parts, subnetting. Okay, slash 27. Now this is our new IP address, with new subnet mask. That is all subnetting is about. Okay, nothing very high level or something like that. That is just the subnetting part here. Alright, now with new subnet mask, now this is also called the first subnet. You have done the subnetting now, and this is the first subnet that you are getting, first subnet. Okay, how you are going to find out the next subnet? It is very simple. Just look at the subnet mask here. Okay, now start from here and just stop at the very last bit, last one bit or the network bit. Okay, find out the place value of that bit. It is 1, 2, 4, 8, 16 and 32. Yes, 32 is the place value of this bit where we have our last network bit, isn't it? Last network bit is at a place value of 32. This is also what we call block size. Okay, let me write it down in different color, otherwise it's going to be confusing. This is also block size. Okay, this block size will be added to this portion, to this octet. This is the interesting octet. This is the octet that we are working on, the last fourth octet. We will add this 192.168.1.32/27, and this is the second subnet. Okay, this is going to be the second subnet. Are you getting my point? Okay, now we will go on and on and on, and we will add the block size to this whole subnets. So let me raise it. It was 192.168.1.0/27. Yes, this was the first subnet. Alright, 192.168.1.32/27, this was the second subnet. Right, there are some IPs that we need to know and their terminologies. The first thing, 168.1.1/27 is the first valid IP. Alright, 192.168.1.31/27 is the broadcast IP. Okay, why 31? I'll explain it in a moment. 192.168.1.30 is the last usable IP or last valid IP. These both IPs can be assigned to a host. Okay, these IPs can be assigned to a host. Meanwhile, this IP address right here, they cannot be assigned to any host. Cannot be assigned to host. Same with this last IP here. Okay, you cannot assign it to a host. Alright, now I was saying that Y31 is the broadcast IP. Yes, let's have a look here. We said that these 3 bits were set to network, isn't it? Okay, that's correct. I'm talking about the fourth octet. Okay, all other bits were 0, right? 0, 0, 0. And when I put this on, it was the first valid IP. Yes, so 1, 2, 4, 8, 16, 32, and what, 64 and 128. Okay, these were the 8 place values here. When I put this one on, I'm actually saying that I just need one IP address. So in the IP address, I will write it down something like this. This is going to be subnet mask. Yes, here subnet mask /27 means you have 24 and plus 3 27 bits to the network portion. Meanwhile, in the IP address, I will write it down in something like this IP address. This is the IP address, and this is the subnet mask. Now if you multiply this subnet mask and the IP address, you'll get what? Yes, if you're going to multiply these, you will get this number, and that is the one. That is the first valid IP. Okay, what about the broadcast IP? We said that again 111 and 00000 were set to the host. Now this was the first case. What about the last case where 111 and all other bits are also ones, which means 1 2 3 4 5. These 5 bits are also ones. What going to be the value here? 1 2 4 8 16. If you add these, 16 plus 8 plus 4 plus 2, because as I mentioned we have to multiply the place value and the digits. So if you multiply this and add 16, 8, 4, 2, 1, you will get 31, which identifies that all the bits in the host portion, this host portion here, are full. So we cannot assign any more IPs to the host. Okay, now since this is the last IP, we usually use it for the broadcast, because it is saying that the network is different. Okay, but the host, there are no hosts basically. Okay, the last valid IP means that there could be and there is a 0 in the host portion. If the host portion is full, that is the binary of host portion all set to ones, then that means that it is a broadcast IP address. Okay, if there is a 0 in the host, it can be assigned to any host. Alright, now broadcast IP and this network IP address, this network ID, cannot be assigned to a single host. These IPs anywhere from 192.168.1.2.3.4.5 till .30 we can assign the hosts. Okay, alright, so that is why we are setting this to broadcast. Okay, now we will move on. We will say 192.168.1.33/27. this is the first valid IP of the second subnet, obviously second subnet. Okay, now if I want to know the last IP, we have this one dot. If I add 32 here, I need to add the block size again. We will get 64. Yes, 63/27/27. Now there will be a bunch of IPs between this 32 and 62. So, excuse me, 33 and 62. Those all are valid IP addresses, and they can be assigned to any host. This is the broadcast of second subnet. Okay, and this is the third subnet. So we are starting with here with this third subnet. I'm going to separate it like this so that it is easy to understand. Okay, again this the network address of the second subnet and the broadcast address of the second subnet cannot be assigned to any host. Okay, now if I want to I hope this is clear. If you have any confusions or questions, please let me know. Now if I want to know that how many hosts are available in this one subnet, okay, how I'm going to do that? There is a formula for this. 2 raised to the power h minus 2 equals whatever the number is. Okay, the host here is the number of bits, number of host bits. What are the host bits? I already mentioned this zeros. Okay, now if I add, there were 3 bits reserved for the network portion. Yes, we borrowed them from the last octet, and there is another 1 2 3 4 5 bits that are set to 0. Yes, in the subnet mask, isn't it? Subnet mask. Now there are 5 bits. I'm going to put them here. 2 raised to the power 5 minus 2 equals what? 32 minus 2 equals 30. So there are 30 IP addresses in every subnet. Okay, there are 30 IP addresses in every subnet. How do you get to know that? By the number of host bits. We can add 30 addresses. Now you can also verify this. Yes, you can go with the 33. These two IP addresses, the broadcast and the network address, cannot be assigned, and that is why I am subtracting 2 here. So we are just left with the IP addresses that are valid and that can be assigned on any host. Okay, if I start with this dot 1, that is a valid IP, first valid IP, and dot 2, dot 3, dot 4, and I will end at dot 30. Yes, that is the last valid IP, here. So you can see that I am getting 30 IP addresses in a subnet. Same here. If I start with 33 and I end up at 62, you will get to know that we are actually getting 30 subnets, or excuse me, 30 IP addresses for this subnet. Same will be applied on the 3rd, 4th, 5th, 6th, 7th, 8th subnets. Okay, because we just have 8 subnets that I mentioned, that we find out by the formula. So 8 subnets will be produced, will be there, but each subnet will have 30 hosts in every network or subnet. All right, now remember this formula. I'm coming back to it. Okay, 2 raised to the power h minus 2 should be equal or greater than your requirement. Now I am talking about the second thing, or the second method, that is by the number of hosts. You can do subnetting according to the number of hosts also. We were doing it by the number of first, second, third, fourth network, right? So we need 5 networks. We came out with 8 networks, and now you will ask that we are still wasting those 3 networks. Yes, we are doing that, but we are actually also utilizing it in the best way. Okay, there could be in fact there is another way, but as of now we are utilizing it for the sake of simplicity and for security purposes and for IPv4 preservation also. Okay, so that was the according to the number of networks. Now what if I go with 50? Okay, and we have what? We have 100, number of hundreds here, 200s, 35. Okay, now in this case you will go with the highest number of IP addresses. Okay, let me make it 150 so that it is better to calculate 150. Okay, in fact let's change it. Not 150, let's do this 80. Okay, 80 IP addresses we need. 100 we need here, 50 here, and 35 here. All right, $80. Okay, now all right, we are here, where we are here. Okay, so our requirement is of maximum 80, excuse me, 100. Yes, that's what we are seeing here. 100 is the maximum number of IPs that we have, that we need. Okay, all others are small, 80, 50, and 35. Okay, 100 is the maximum requirement. Now I will set this bit, this h, in such a way that this requirement is fulfilled. So let's say 2 raised to the power 7 is 128. Okay, minus 2, so 128 minus 2 is 100. 126 is greater than or equal to 100. Getting the point here? Why I just why I'm not using those 200 IPs and took that 200? That is why. Okay, 2 raised to the power 7. Now this means that we need 7 bits for the host portion. We need to fix that. Okay, we need to fix that. Now we were doing it in a different way, or we can say, let me just explain. 192.168.1.0, okay, /24, that was the default IP address. We did subnetting here. Now let me take again, this is the subnet mask dot 0. Yes, now let me take this yeah, right here, 00, and expand it. Okay, what we were doing is we were setting these 3 bits to ones, right? Okay, so we were doing something like this. Now we are setting not the network bits, we are not borrowing any network bits. But what we are doing is we are setting 7 bits to host. Now there are 1 2 3 4 5 6 7 and 8 bits. Yes, there are 8 bits in an octet. What I'm going to do is I'm going to set these 1 2 3 4 5 6 7 all to 0, and last one for the network. So my network subnet mask is going to be something like this. It is going to be something like this: 1 2 3 4 5 6 7 and 8. Fourth octet, remember this. Okay, in the fourth octet I am just setting 1 to 0. Meanwhile 1 bit to 1. Meanwhile all other bits to 0. Why I am doing that? Because I know that I need 7 bits in order to make 100 IP addresses, or in order to utilize 100 IP addresses. Okay, that's why we are doing this. So we are setting these bits to 0, and we just left the 1 bit to the network portion. We don't need that. That's why we are setting it to network, so that any other network can be assigned here, or any other network can be used. Now this means that the network here is going to be looking something like this. Sorry, the new IP address 192.168.1.0 and /25. Yes, it was here till /24. Yes, I borrowed this one, or let's say that I just fixed this one to network here. So there are 25 bits in the network portion now. Alright, this is going to be the new IP address. Also this is going to be the new IP address, and also the network bit of network address of first subnet. Again, this is going to be the first subnet here. Okay, this is the network address, network ID. As we did in the last process, there is a block size as 128 192.168.1.0 here, and I am going to add it to this like this. Okay, .128/25. This is the second subnet, and this is the network ID of the second subnet. Okay, between these there are multiple IPs: 192.168.1.1. yes, 1.2, 1.3, 1.4, 192.168.1. You will end at 127/25. That is going to be the broadcast IP. Just before that is 192.168.1.126/25, and that is the last IP address. This is the first valid IP. Right? Okay, that's great. That we are going good. Now I will write 192.168.1.129 and on and on. What if I want to add another network here, which means that I want to add 128 again to this? So 128 plus 128 we will be left with 256. Yes, and obviously you know that this is not possible. 256 is not possible because we have 8 bits in an octet, and the total of those 8 bits, the sum of those 8 bits is 256. 255. That is the maximum number of bits you can choose here, and we are going to 256, so that is not possible. So we will only have 2 subnets here. You can also verify this by the previous formula, 2 raised to the power n, where n is the number of network bits, you remember. So I will, number of network bits is 1 here in the 4th octet, that will be equal to 2. 2 raised to the power 1 is 2. Okay, now there is a one presentation of this subnet mask here. Another presentation would be in the decimal system also. So as I just on this bit here 128, so I will write the subnet mask something like this, dot 128. Why? Because we are still adding these 3 bits, excuse me, octets, and I'm just using the first octet here. So that's first bit here in the last octet, that's why I'm putting this to 1. Okay, now in the previous example also, where we have /27, we will add 1 2 3 1 2 3 4 5. Yes, so I will add 128, 64 and 32, and we will get 224. So I will write the subnet mask for the previous example as 255.255.255.224 in the 4th octet. So that is another kind of representation for a new subnet mask, that other than the /25, and that is normally what we use in order to assign any IP address in a network or at interface. Okay, so that was all about the subnetting. Now I'm going to share you this subnet ipv4.com. okay, and let me show you how it works so that it is clear to you. I'll go to it. This is subnet ipv4.com. okay, that is the website name here. You will have an interface something like this where you will practice subnetting. Okay, now there is a new problem option here, and there is a target IP address. If you want to put some inputs here, you can do that. You have option to do that. You can add anything, 128, okay, 150, 0, and let's say 25. And I'm going to add kind of another thing or another subnet mask here, and that is going to be, that would be, let's say 27. okay, so that's how you can do that. Or what you can do is you can just click on the new problem, and they will give you a new random IP address with a random subnet mask. okay, again, if I add new problem, again a new problem is appearing. Now what you need to do is you need to solve it as a process of subnetting, the same thing that we did. okay, you will have your answer here. okay, just add your answer here. Let's say 212.195.20, and it is asking for /28. Now if you are going to solve this, let me do it here. 212.195.20.102, 212.195.20.102/28. okay, you will do it something like this. 212 is going to be same, 195 is going to be same, 20 is going to be same, because till here we are getting 24 bits. okay, and now it is 28, which means 1 2 3 4 bits have been borrowed, 25, 26, 27, 28, and all the bits are 0. okay, now you have to make 102, 102. How will you make it? okay, add 128, 64, 32, 16, 8, 4 to 1. What values should you add in order to get 102? You cannot add 128, it's going to be 0. You can add 64, it is 1. okay, can you add 32? Let us see. 64 plus 32, it's going to be 96. Yes, we can add 32 also. How much we need 96 to add on to 102. I think it's 6. Yes, we need 6. So 8 is 0, 16 is 0, 4 is 1, 2 is 1, and 1 is 0. Okay, so we will write 0 1 1 0 0. Okay, and 0 1 1 0. Am I correct? No, I am not. I just made a mistake here. To correct it, we need just a moment. 0 1 1 0 and 0 1 1 0. That's how you will get 102. Okay, so that is the IP address. Okay, now where is the dividing line? Here is the dividing line. This is where subnet mask, the network portion of the subnet mask is ending and the host portion is starting. You will do multiplication of these. Okay, multiply these 0 1 1 0 and 0 0 0 0. What you're going to get is 96. Yes, 96, which means that 212.195.20.96/28 is the network ID. Let us see. Dot 96. Okay, once you write this IP here, check this. It's correct? Yes. If you did something wrong here, let's say I did something wrong here, if I check now, it's saying no. So what is the correct answer? You will click on show and it will show you the correct IP address. Okay, same goes with the first host. Again, if I want to know the first host, just add 96. Okay, and just add 97. That is going to be the first host. 212.195.20.96 is the network ID, and 97 is going to be the first host here. Second host is going to be 195.20.98.99 and so on and on. Okay, let's try this one also. So 212.195.20 and what I said 96. Yes, check. It's not correct. Excuse me, that was 97. This was 96. So I will check. Yes, 97. Yes, right. You will look at show. If you are not correct here, you can just make it show. What is going to be the last host? Obviously I just told you that we need to add this block size here, this bit here. It has a place value of 16. Yes, 128, 64, 32 and 16. So 16 is the place value here. This is the block size. Okay, you will add this block size to the interesting octet, to this. So 96 plus 16 is going to be 12, 10 or 1 is 11, 112. Yes, 112. Let's check this out. 195, 20 and 112. Excuse me, we need to know one thing here. That is going to be the second subnet. Okay, second subnet. So we will say that 212 dot, in fact let me write it here. When you start with the first IP, second IP, third IP, something like that, you will end up with this 195.20.112. that is the second subnet. Okay, just before that you have 212.195.20.111. yes, just before that you have 195.20.110. that is the last IP and that is the broadcast IP. Okay, I'm going to write it here, last and broadcast. Okay, so 110 is the last host. 110, let me check it. Yes, that's correct. What is going to be the broadcast IP? 195, 20 and 111. Let me check. Yes, that's correct. And what's going to be the next subnet? It is obvious, 195.20.112. Okay, check this out. Yes, that's correct. Show. If you want, you can just click on the show right here. Okay, if you are correct, you don't need to write it down, you just need to verify your answer, then you can just go with the show. If you are correct, that is good. If you are not, try to find out your problem, and if you cannot find out the problem, we will be discussing it in the next class. Okay, new problem, you can go with the show also. Just at the same time, you can show all the answers here. Okay, all right, that's all for today. Practice this, and we'll meet in the next class.